In the vast, star-dusted expanse of the cosmos, where mysteries drift silently through the void, humanity has just witnessed a moment of profound connection. The James Webb Space Telescope, a marvel of engineering and a beacon of human curiosity, has turned its gaze toward an enigmatic traveler from beyond our solar system, the interstellar object known as 3I/ATLAS. Discovered on July 1st, 2025 by the NASA-funded ATLAS survey, this cosmic wanderer has captivated astronomers and dreamers alike, offering a rare glimpse into the distant realms of another star system. With its latest observation, captured at 5:38 p.m. PKT on Sunday, September 14th, 2025, Webb has delivered the clearest image ever of an interstellar visitor, a breathtaking snapshot that not only redefines our understanding of the universe, but also stirs the imagination with its vivid detail and profound implications. This is the story of 3I/ATLAS, a fragment of another world, a fleeting guest in our cosmic backyard, and a testament to humanity's relentless pursuit of knowledge. Picture this, a faint speck of light hurtling through the infinite darkness at unimaginable speeds, its surface etched with the secrets of a star system light years away. This is 3I/ATLAS, an interstellar object that defies the familiar rhythms of our solar system. Unlike the comets and asteroids that orbit our sun, 3I/ATLAS is a cosmic nomad cast out from its home system millions, perhaps billions, of years ago. Its journey through the interstellar void has brought it to our doorstep, a brief encounter that will never repeat. On September 14th, 2025, the James Webb Space Telescope, perched a million miles from Earth, locked onto this elusive traveler and captured an image of such clarity that it has sent ripples of excitement through the scientific community and beyond. The image is nothing short of mesmerizing. Against the inky blackness of space, 3I/ATLAS glows with an otherworldly radiance, its nucleus surrounded by a shimmering halo of dust and gas. Webb's infrared instruments have peeled back layers of mystery, revealing intricate textures, subtle emissions, and a complex coma, a gaseous envelope that dances with jets and tails. Where older telescopes might have seen only a blurred streak, Webb's precision unveils a portrait of astonishing detail, a visual symphony that sings of distant worlds and ancient journeys. This is not just a photograph, it is a window into the chemistry, history, and dynamics of a fragment born under another sun. The James Webb Space Telescope, launched in December 2021, is the most advanced observatory ever built, designed to probe the deepest reaches of the cosmos. Its 6.5-meter mirror, gilded in gold, captures light from the universe's earliest galaxies, but its versatility has proven equally adept at studying objects much closer to home. For 3I/ATLAS, Webb's infrared sensitivity is a game changer. Unlike optical telescopes that rely on visible light, Webb can peer through cosmic dust and detect the faint thermal glow of cold, distant objects. This capability has allowed it to resolve 3I/ATLAS with unprecedented sharpness, transforming what might have been a fleeting glimpse into a treasure trove of data. The image reveals a nucleus with defined contours, surrounded by a coma that pulses with activity. Jets of gas and dust, triggered by the sun's heat, spiral outward in asymmetrical patterns, hinting at an internal composition unlike anything seen in our solar system's comets. Spectral readings from Webb's instruments break the light into chemical fingerprints, identifying water vapor, carbon dioxide, methane, and possibly even complex organic molecules. Each signature is a clue to the object's origins, a diary written in the language of chemistry that tells of the conditions in its home star system. This is science at its most thrilling, a detective story unfolding across light years. What makes 3I/ATLAS so extraordinary is its status as an interstellar interloper, only the third confirmed object of its kind, following the enigmatic Oumuamua in 2017 and the comet-like 2I/Borisov in 2019. 3I/ATLAS represents a rare opportunity to study material from beyond our solar system. Oumuamua, with its peculiar elongated shape and lack of a visible coma, left astronomers with more questions than answers, while Borisov offered a more familiar cometary profile, but lacked detailed imaging. 3I/ATLAS, however, is a revelation. Its hyperbolic trajectory, a path that will carry it through our solar system and back into the interstellar void, marks it as a one-time visitor, a cosmic postcard delivered and then lost forever. The image captured by Webb is a fleeting record of this encounter, a moment frozen in time that encapsulates millennia of wandering. The object's coma, with its irregular jets and unusual gas ratios, shows suggests a chemistry shaped by a star system with different conditions than our own. Perhaps it formed in the icy outskirts of a young star where volatiles froze into its core. Or maybe it was forged closer to its parent star, bearing the scars of intense radiation. The data from Webb allows scientists to compare 3I/ATLAS with our solar system's comets, probing whether the building blocks of planets and life are universal or unique. If familiar materials like water ice dominate, it hints at a shared recipe across the galaxy. If exotic compounds appear, it suggests a diversity of planetary formation processes, each star system a unique alchemical laboratory. The implications of this discovery ripple across astronomy, chemistry, and even astrobiology. By analyzing the spectral data, scientists can map the chemical composition of 3I/ATLAS, searching for organic molecules that might mirror those that seeded life on Earth. The presence of carbon-bearing compounds would bolster the hypothesis that the raw ingredients of biology are scattered widely across the galaxy, hitchhiking on comets and asteroids. While this alone doesn't prove life exists elsewhere, it underscores a tantalizing possibility that the chemistry of life is not a fluke confined to our solar system, but a common thread woven through the cosmos. The dynamics of 3I/ATLAS's journey add another layer of intrigue. Ejected from its home system, likely through a gravitational slingshot by a massive planet, it has drifted through the interstellar medium, battered by cosmic rays and micrometeoroids. Webb's image captures the weathered surface alongside fresher materials exposed by solar heating, offering a before and after snapshot of its cosmic odyssey. This dual perspective reveals how interstellar travel alters an object's chemistry, providing a baseline for understanding the life cycle of galactic debris. It's as if 3I/ATLAS is a time capsule, preserving the history of its formation and the scars of its travels. The observation of 3I/ATLAS challenges us to rethink the galaxy as a dynamic, interconnected system. For centuries, astronomers viewed star systems as isolated islands, their planets and comets bound by their parent star's gravity. But objects like 3I/ATLAS reveal a galaxy alive with exchange, where material is flung between systems, carrying the seeds of planets and perhaps life itself. Each interstellar visitor is a data point in a larger map, tracing streams of debris that crisscross the Milky Way. By studying 3I/ATLAS, scientists can begin to chart these streams, identifying regions where stellar interactions are frequent or where planetary systems are disrupted. This galactic ecosystem has practical implications too. Understanding the trajectories and compositions of interstellar objects enhances our models of celestial dynamics, which could prove vital for planetary defense. While 3I/ATLAS poses no threat, a larger object on a collision course with Earth would demand precise tracking and analysis. Webb's success in imaging this visitor demonstrates that we have the tools to study such objects in detail, preparing us for future encounters. It's a reminder that exploration and preparedness go hand in hand, each discovery a step towards safeguarding our planet. Beyond the science, the image of 3I/ATLAS resonates on a deeply human level. There's something profoundly moving about gazing upon a fragment from another star system, its surface etched with stories of distant worlds. It evokes the same awe inspired by the first images of Earth from space or the Hubble Deep Field, a sense of standing on the threshold of the unknown. This single frame condenses the immensity of interstellar distances into something tangible, a reminder that the universe is not a static backdrop, but a living tapestry of motion and exchange. For students, educators, and enthusiasts, the image is a call to wonder. It sparks curiosity, inviting new generations to explore astronomy, physics, and engineering. It shows that discovery is not confined to textbooks, but is unfolding now, accessible to anyone with a passion for the stars. The clarity of 3I/ATLAS is a beacon, illuminating the path for future scientists and explorers. Share your thoughts in the comments below. What does this image inspire in you? Let's start a conversation about the wonders of the cosmos. The capture of 3I/ATLAS is a testament to human ingenuity and collaboration. Detecting and imaging an object moving at tremendous velocity required a symphony of technology. Ground-based telescopes like ATLAS first flagged the object, orbital instruments refined its trajectory, and Webb's unparalleled resolution delivered the definitive image. Behind the scenes, data processing pipelines and machine learning algorithms ensured that every pixel was crisp and meaningful. This synergy reflects the modern era of astronomy, where global networks of observatories and computational power amplify human observation. The engineering feat is staggering. Webb's instruments had to lock onto a faint, fast-moving target, compensating for its motion and the telescope's own orbit around the sun. The result is not just a picture, but proof that humanity can achieve what was once thought impossible. This success sets the stage for future observations from other interstellar visitors to distant galaxies, reinforcing Webb's role as a versatile observatory ready for the unexpected. The image of 3I/Atlas is not an endpoint, but a beginning. It marks the start of a new chapter in interstellar science, where objects once confined to theory are now vivid realities. With each new visitor, astronomers can refine their understanding of galactic dynamics, chemical diversity, and the potential for life beyond our solar system. Webb's early success, just a few years into its mission, promises decades of similar discoveries, building a gallery of interstellar objects that chart the Milky Way's complexity. The observation also reshapes how we categorize these cosmic wanderers. Oumuamua's odd shape and Borisov's cometary nature hinted at a spectrum of possibilities, but 3I/Atlas adds a hybrid perspective. Its unique features, irregular jets, unusual gas ratios, and a weathered surface suggest a new taxonomy for interstellar objects, one that accounts for their diversity. This reclassification will guide future searches, ensuring we're ready to detect and study the next visitor. At its core, the image of 3I/Atlas is a mirror reflecting humanity's place in the cosmos. Just as this object has traveled across the stars, we too are explorers, sending probes like Voyager into the interstellar void. The image reminds us that we are part of a larger galactic story, one where matter, chemistry, and perhaps life are shared across vast distances. It's a humbling yet exhilarating thought that a fragment from another star system can connect us to the broader universe, sparking dreams of our own cosmic journeys. This moment also underscores the value of ambitious scientific endeavors. The James Webb Space Telescope, a decades-long project, represents a leap of faith in the power of curiosity. Its image of 3I/Atlas is a gift to humanity, a reminder that exploration expands not just our knowledge, but our sense of possibility. As you marvel at this cosmic traveler, consider sharing your excitement with others. Let's inspire each other to keep looking up. The journey of 3I/Atlas through our solar system is a cosmic dance, choreographed by the intricate interplay of gravitational forces, solar radiation, and the object's own internal dynamics. As it approaches the sun, the heat triggers sublimation, transforming frozen ices into vibrant jets of gas and dust that spiral into the void. Webb's image captures this spectacle in exquisite detail, revealing a coma that pulses with life. Its asymmetrical patterns, a testament to the object's unique composition. These jets are not mere decorations. They are clues to the physical processes at work. Each twist and turn a record of the stresses 3I/Atlas endures as it navigates our solar system. The clarity of the image allows scientists to track these features with precision, measuring the rates of sublimation and the ratios of gases like carbon dioxide and methane. These measurements offer a window into the object's internal structure, suggesting a nucleus that may be a patchwork of icy and rocky materials shaped by a star system with a different thermal and chemical history than our own. This dance is fleeting, as 3I/Atlas follows its hyperbolic path, destined to exit our solar system and vanish into the interstellar void. The urgency of this moment, knowing that we have only this brief encounter to study the object, lends a dramatic weight to Webb's achievement. It's a reminder that the universe is a place of constant motion, where opportunities for discovery are as transient as they are profound. Imagine standing on the edge of a cosmic shore, watching a ship from a distant land sail past, its sails catching the light for just a moment before it disappears over the horizon. That's what 3I/Atlas represents, a fleeting visitor whose story we are privileged to witness, thanks to the unparalleled vision of the James Webb Space Telescope. What does this cosmic dance evoke for you? Share your thoughts in the comments, and let's explore the beauty of this celestial performance together. The image of 3I/Atlas is more than a snapshot. It's a thread in the rich tapestry of galactic stories that connects star systems across the Milky Way. Each interstellar object like 3I/Atlas carries a narrative of its own, a chronicle of formation, ejection, and survival through eons of interstellar travel. By capturing this object in such vivid detail, Webb allows us to read its story with unprecedented clarity, piecing together the conditions of its birth and the trials of its journey. The spectral data reveals a chemical profile that might include water ice, suggesting formation in a cold, distant region of its parent system, or complex organics, hinting at the potential for prebiotic chemistry. These findings place 3I/Atlas within a broader context, linking it to the processes that form planets and, possibly, the seeds of life. The object's weathered surface, scarred by cosmic rays and micrometeoroids, tells of its long sojourn through the interstellar medium, a testament to the resilience of matter in the face of the galaxy's harsh environment. This single image, then, is a chapter in a larger saga, one that connects our solar system to countless others. It challenges us to imagine a galaxy where debris flows like rivers between stars, carrying materials that might one day spark new worlds. The study of 3I/Atlas is a step toward mapping these rivers, identifying the pathways that link star systems and the mechanisms that drive galactic exchange. For scientists, this is an opportunity to refine models of stellar evolution and planetary formation, asking whether the processes we observe in our solar system are echoed elsewhere, or if each system writes its own unique story. For the rest of us, it's a chance to marvel at the interconnectedness of the cosmos, to see our place within a grand narrative that spans light years. How does this idea of a galactic tapestry resonate with you? Drop your thoughts in the comments, and let's weave our own stories into this cosmic narrative. The legacy of 3I/Atlas extends far beyond its brief passage through our solar system, casting a long shadow over the future of astronomy and human exploration. This image, captured by Webb on September 14th, 2025, is a milestone that will shape scientific inquiry for decades to come. Researchers will pore over its details, using the spectral data to test hypotheses about the universality of chemical processes and the diversity of planetary systems. The irregularities in the coma, the unexpected absorption lines in the spectra, and the subtle variations in the nucleus's reflectivity are not just anomalies, but invitations to deeper understanding. These puzzles will inspire new experiments, new models, and perhaps new missions designed to intercept future interstellar visitors. The clarity of this image also sets a benchmark for what's possible, proving that humanity can capture and study objects that were once mere blips in the night sky. This achievement will fuel the development of next-generation observatories and even spacecraft capable of rendezvousing with such objects, perhaps collecting samples to bring back to Earth. For educators, the image is a powerful tool to ignite curiosity, showing students that the universe is not a distant abstraction, but a place of tangible wonders waiting to be explored. For the public, it's a shared moment of awe, a reminder that we are all part of a species reaching outward, driven by a desire to understand our place among the stars. The story of 3I/Atlas will live on in textbooks, documentaries, and the imaginations of those who gaze at the image and feel the pull of the cosmos. It's a legacy of discovery, connection, and possibility. A single frame that captures the essence of what it means to be human in a universe full of mysteries. What legacy do you think 3I/Atlas will leave for future generations? Share your ideas in the comments, and let's dream about the next chapter of cosmic exploration. The observation of 3I/Atlas transforms our solar system into an interstellar laboratory, a unique testing ground where scientists can study the physics and chemistry of a visitor from another star system under the controlled conditions of our sun's influence. As 3I/Atlas passes closer to the sun, its surface undergoes dramatic changes, with volatile ices sublimating into vibrant jets that create a dynamic coma, visible in stunning detail through Webb's infrared lens. These jets, with their intricate curls and unexpected asymmetries, are not just visually striking but scientifically invaluable, offering insights into the object's internal structure and the processes that govern its behavior. By analyzing the spectral signatures of the gases, carbon dioxide, methane, ammonia, and potentially complex hydrocarbons, scientists can infer the thermal history of 3I/Atlas, piecing together whether it formed in the frigid outer reaches of its home system or closer to a star's searing heat. The image also captures subtle variations in the nucleus's reflectivity, hinting at a heterogeneous composition, perhaps a mix of icy crusts and rocky aggregates, sculpted by eons of cosmic weathering. This laboratory setting allows researchers to compare 3I/Atlas directly with solar system comets, probing whether the physical laws that shape cometary activity are universal, or if interstellar objects follow different rules, shaped by the unique conditions of their birthplaces. The fleeting nature of this encounter adds urgency to the study, as every observation observation must be maximized before 3I/Atlas exits our reach forever. This moment is a rare gift, a chance to conduct experiments on a cosmic scale, using the sun as a natural probe to unlock the secrets of a distant world. The data from Webb's image will fuel simulations and models, helping scientists predict how future interstellar objects might behave and informing the design of missions to intercept them. For those watching from Earth, this interstellar laboratory sparks a sense of shared discovery, inviting us to ponder the universal forces that connect our solar system to the broader galaxy. What questions does this cosmic experiment raise for you? Share your curiosity in the comments, and let's explore the possibilities of this interstellar laboratory together. The image of 3I/Atlas serves as a bridge between worlds, linking the familiar terrain of our solar system with the uncharted territories of another star system. This interstellar visitor, carrying the chemical and physical imprints of its origin, offers a tangible connection to a place we may never visit, a star system whose light might still be traveling toward us across the vastness of space. Webb's image reveals a nucleus scarred by cosmic rays and micrometeoroids, a surface that tells of a journey through the interstellar medium where particles and radiation have sculpted its features over millions of years. Yet, as the sun's warmth awakens fresh material from within, the image also shows pristine layers, untouched by the ravages of space, offering a glimpse into the pristine conditions of its formation. This duality between the weathered exterior and the preserved interior makes 3I/Atlas a unique artifact, a messenger that carries the story of its home system while revealing how it has been transformed by its travels. The spectral data, with its hints of organic molecules, raises profound questions about the universality of life's building blocks, suggesting that the chemistry that sparked biology on Earth might be a common feature of star-forming regions across the galaxy. This bridge extends beyond science, touching on philosophical and cultural dimensions, as it invites us to see ourselves as part of a cosmic continuum where matter and stories flow between stars. The image challenges us to imagine the countless other systems out there, each with its own comets, planets, and possibilities, and to consider how our own solar system might contribute to this galactic exchange, sending its own debris into the void. For astronomers, this bridge is a call to action, urging them to refine their tools and techniques to catch more of these fleeting visitors, building a catalog of interstellar objects that could one day reveal the broader architecture of the Milky Way. For the rest of us, it's an invitation to dream, to wonder what other bridges we might build through science, exploration, or imagination to connect with the distant corners of the cosmos. How does this idea of a cosmic bridge inspire you? Drop your thoughts in the comments and let's build connections across the stars. The image of 3I/Atlas is not just a scientific triumph, but a cultural phenomenon, resonating across borders, disciplines, and generations with its power to evoke wonder and unity. Throughout history, celestial events, comets, eclipses, and supernovae have captured the human imagination, often seen as omens or symbols of change. Today, with Webb's crystal-clear portrait of 3I/Atlas, we've transformed these ancient symbols into objects of profound understanding, yet the awe remains undiminished. This single frame, shared across media platforms, social networks, and classrooms worldwide, has become a global touchstone, a shared moment where people from all walks of life pause to marvel at the universe's grandeur. The image's vivid detail, the glowing coma, the intricate jets, the subtle textures of the nucleus, makes the abstract concept of interstellar travel immediate and relatable, inviting everyone to feel part of this cosmic encounter. For artists, it's a muse, inspiring works that capture the beauty and mystery of a traveler from another star. For educators, it's a catalyst, sparking discussions about science, technology, and humanity's place in the cosmos. For the public, it's a reminder that discovery is a collective endeavor, one that transcends national boundaries and unites us in our shared curiosity. The cultural resonance of this image lies in its ability to bridge the scientific and the emotional, offering a visual testament to humanity's capacity to reach beyond the familiar and touch the unknown. As people share their reactions, whether through art, conversation, or social media posts, the image becomes a catalyst for dialogue, encouraging us to ask big questions about our origins, our future, and our role in the galaxy. This moment also highlights the power of science to inspire, showing that investments in exploration yield not just data, but moments of connection that define what it means to be human. How has the image of 3I/Atlas touched you? Share your reflections in the comments, and let's celebrate the cultural impact of this cosmic snapshot together. The clearest image of 3I/Atlas will endure as a landmark in astronomy. Scientists will return to it as new theories emerge, comparing its details with future interstellar objects. Educators will use it to ignite curiosity, showing that the universe is within our reach. Enthusiasts will cherish it as a moment when the abstract became tangible, a fleeting visitor brought into focus by human ingenuity. Alongside iconic images like Earthrise and the Hubble Deep Field, it will stand as a symbol of our expanding horizons. As we continue to study 3I/Atlas, new questions will arise. What do its chemical signatures reveal about the universality of life's building blocks? How do its dynamics inform our models of galactic exchange? What anomalies challenge our assumptions, pushing science forward? Each inquiry is a step toward a deeper understanding of the cosmos, with Webb's image as the foundation. The story of 3I/Atlas is a reminder that the universe is alive with motion, exchange, and encounters. Every interstellar object that passes through our solar system carries the history of another world, and Webb has given us the tools to read those stories. This image is more than a photograph. It's a message from the stars, decoded by human persistence and vision. It tells us that the cosmos is vast, interconnected, and brimming with discovery, waiting for us to explore its endless wonders. How does the image of 3I/Atlas inspire you to think about our place in the universe? Share your thoughts below and let's keep the conversation going. Together, we can celebrate the awe of discovery and the power of human curiosity to unlock the secrets of the stars.